You studied before that the ionic bond, it's a kind of electrostatic attraction between positive and negative ions. So it's a bond arises between a metal and a non-metal. Why? Let's revise. Because metals are characterized by large atomic size and, as a result, low ionization energy. So they tend to lose valence electrons, forming positive ions, cations, which their electronic configuration is similar to that of the nearest noble gas that precede them in the periodic table. While nonmetals are characterized by their small atomic sizes and their high electron affinities. So they tend to gain electrons, forming negative ions, anions. Their electronic configuration is similar to the nearest noble gas that followed them in the periodic table. So, at the end, we have positive ion and negative ion, and there is a kind of electrostatic attraction between them, which is called the ionic bond. As we can see here in this example, if we have sodium and chlorine, we can get sodium ion and chloride ion to form sodium chloride ion. But the new information for this year that the difference in electronegativity that you studied in the last term between the metal and the non-metal here must be greater than 1.7. Otherwise, it's gonna be a covalent bond. Look here, we have elements like sodium, magnesium, aluminum. And you have the electronegativity of each one of them and the element chloride and the difference in electronegativity between them inside each compound. Look here at the end of this table, look at the electrical conductivity of chloride melt. In case of sodium chloride, it's very good conductor, while magnesium chloride just good conductor, while aluminum chloride does not conduct electricity. So, if the difference is greater than 1.7, we have an ionic compound. And it's a good conductor of electricity. While, as this difference is less than 1.7, it's a covalent compound. So, aluminum chloride, it's a covalent compound, not an ionic compound. Despite that it contains aluminum and chlorine, metal and non-metal, positive ion and negative ion. So, this year, we need to complete the definition of ionic bond. It's an electrostatic attraction between positive ion and negative ion, and the difference in electronegativity between them must be greater than 1.7. So, the ionic bond, it's the chemical bond which is formed between metals and non-metals. The difference in electronegativity between them is more than 1.7. Here, for example, sodium chloride has strong ionic properties because the difference in electronegativity between the two elements that form this compound is higher than 1.7. Number 2, although chlorine is a non-metal and aluminum is a metal, but aluminum chloride showed the properties of the covalent bonds here because the difference in electronegativity between aluminum and chlorine is less than 1.7. In addition, look here. Sodium chloride is a very good conductor of electricity, while magnesium chloride just good conductor. Look here, as the difference between the two elements or the element that form the ionic compound, the difference in electronegativity increases the ionic properties increases also. This is why sodium chloride is a very good conductor of electricity, while magnesium chloride just good conductor.